So in this video, I am going to explain about organic chemistry. So in this we'll discuss the following concepts. First, general introduction, nomenclature of organic compounds, isomerism, fundamental concepts in organic reaction mechanism, types of organic reactions and their mechanism, methods of purification of organic compounds, qualitative and quantitative analysis. Next, hydrocarbons, alkenes and aromatic hydrocarbons. We will discuss. First, general introduction. The first organic compound synthesized from other compound in laboratory is urea by Euler. So this is the first organic compound prepared in the laboratory from compound by Euler. Next, acetic acid prepared by Kolbe and methane by Berthelot. So these two compounds are prepared by from their constituent elements. Next, valency of carbon atom in organic compounds is 4. Therefore, carbon is also known as tetravalent element. Next, hybridization of carbon atom in methane, ethane and ethane. Methane, ethane and ethane, sp3, sp2, sp respectively. So first one, methane alkane, ethane alkene, ethane alkyne. Next, on increasing S character, electronegativity of carbon increases. Very, very important. So you can write electronegativity order Sp greater than Sp2 greater than Sp3. Electronegativity. So as the percentage of S character increases, electronegativity of that carbon also increases. Next. See here, electronegativity order is given. SD contrails also same. Next, carbon atom with sp hybridization is more electronegative. Next, unsaturated organic compounds are more reactive due to pi electron cloud located above and below of plane of bonded atoms. So, due to the presence of pi bonds, unsaturated compounds are more reactive. Next, so three-dimensional representation of methane on paper is shown below. So, which is given by like this. See here, methane tetravalent. So around carbon 4 bonds will be there. Out of 4 bonds, 2 bonds will be in one plane. Third bond above the plane. Fourth one below the plane. Next. See, organic compounds which consist of straight or branched chains are also known as open chain or acyclic compounds. Next. Organic compounds contain carbon atom in the form of ring, homocyclic or heterocyclic, are called as alicyclic or closed chain or ring compounds. Homocyclic means containing only carbon atom in ring. Heterocyclic means in addition to carbon atoms, some hetero atoms will be there. Next, a group or series of organic compounds with same general formula and a characteristic functional group which differ by CH2 group. Adjacent members are differ by CH2 group are known as homologous series of compounds. Next, an atom or group of atoms which are responsible for characteristic chemical properties of organic compounds are known as functional groups. So, functional group is reactive part of the molecule. Reactive part. Reactive part of the molecule. Very, very important. So, in case of homologous series, two adjacent members are differ by CH2 group. That is molecular weight differ by 14. Next. So, nomenclature of organic compounds. Organic compounds in which carbon atom forms multiple bonds. Multiple bonds means here double bonds or triple bonds are unsaturated compounds, unsaturated hydrocarbons. So double bonds means you can write like this. So triple bonds like this. These two are multiple bonds. Next, single bonds means you can write like this. Carbon carbon single bond. So a carbon carbon distance we can write 1.54 angstrom units. Here 1.34 angstrom units. Here 1.2 angstrom units. Remember carbon carbon bond length also. Next. The functional group of alcohols is OH and the secondary suffix is ol. Functional group of aldehydes is CHO, secondary suffix is ol. Ketone CO and secondary suffix is on. Next. Cyanides is CN, secondary suffix is nitrile. Next. Functional group of ethers are OR. O is functional group, ethers. Carboxylic acid, COOH, secondary suffix is oic acid. COR, esters, secondary suffix is oate. That means complete name is alkyl alkanoate. Next, acid halide COX, secondary suffix is oil halide. Remember here functional groups and their secondary suffix name. Next. So functional group of amines is CnH2, secondary suffix is amine. Next, functional group of amide CONH2, secondary suffix is amide. Next, so general structure for IUPAC name is secondary prefix, primary prefix, root word, primary suffix and secondary suffix. So root word indicates maximum number, that means total number of carbon atoms in longest possible chain, which is known as parent chain. Number of carbon atoms in longest possible chain. Primary suffix represents saturation or unsaturation. Secondary suffix indicates main functional group. Next, primary prefix indicates cyclo or bicyclo or spiro in case of cyclic compounds. Secondary prefix represents nature of substituents. So this is order of decreasing priority of functional groups. First COOH, next SO3H, next ester, acid halides, amides, cyanides, aldehydes, ketones, alcohols, amines, double bond and triple bond. Next, one more important point here, epoxy. Epoxy means like this, epoxy. Next, OR, alkoxy, NO2, nitro, NO, nitroso, X, halo. So these are always prefixes. Prefixes always. Very, very important. Epoxides, alkoxides, nitro, nitroso and halo are always used as prefixes. These are not functional groups at all. Next. Isomerism. What is meant by isomerism? Phenomenon of existence of two or more compounds possessing same molecular formula but different properties are known as isomers, and the phenomenon is isomerism. Compounds are isomers and phenomenon is isomerism. Okay, next. Here, two or more compounds having same molecular formula but different carbon skeleton are known as chain isomers or nuclear isomers. Chain isomers or nuclear or skeletal isomerism. Difference in length of carbon chain, that means carbon skeleton. Next, two or more compounds having same molecular formula but differ in position of substituent or functional group or multiple bonds. See here, or multiple bonds are known as functional isomers, that means positional isomers, and the phenomenon is positional isomerism. So two or more compounds having same molecular formula but differ in nature of functional group are functional isomers, and the phenomenon is functional group isomerism. Next, phenomenon of existence of two or more compounds possessing same molecular formula but differ in nature of alkyl groups attached to the main functional group are known as metamers, and the phenomenon is metamerism. So metamerism is due to difference in nature of alkyl groups attached to the same polyvalent functional group. So fundamental concepts in reaction mechanism are very important. Homolysis cleavage leads to formation of free radicals. Homolysis gives formation of free radicals. So which are sp, free radicals are not sp3, sp2, right? sp2, sp2 and paramagnetic sp2. Next, heterolytic cleavage leads to formation of carbocations and carbanions. Carbocations means positive charge, carbon with positive charge, carbanions, carbon with negative charge. Next, carbocations are trigonal planar shape and sp2 hybridization. So, stability of carbocations, methyl, primary, secondary, tertiary, increasing order. Tertiary more stable. Next, order of stability of alkyl free radicals. Same order. CH3 radical. The radical should be there. Free radical. Methyl radical, primary, secondary, tertiary radicals, increasing order. Next, the reagent with an electron pair or free lone pair is nucleophile. So, nucleophile means you can take it as Lewis base that can donate. Next, the reagent which is electron seeking, that means electron accepting, is known as electrophile. H plus, R plus, CCl2, BCl3, AlCl3. So these are Lewis acids. Lewis acids. So these two are reagents. So reagents, electrophiles and the nucleophile. Electrophile is represented with E plus and nucleophile Nu minus. So electrophiles are electron deficient and nucleophiles are electron rich. So these two are known as attacking reagents. So electrophiles are Lewis acids, nucleophiles are Lewis bases. Remember this point. Next, the polarization of sigma bond caused by polarization of adjacent sigma bond is called inductive effect or transmission effect or propagation effect. So inductive effect propagates through sigma bonds. Next, the group which can release electrons relative to hydrogen or plus I groups, that means electron donating groups. All alkyl groups are plus I groups. The group which can withdraw electrons relative to hydrogen are minus I groups. So functional groups NO2, CN, COOH, COR. So except alkyl groups remaining are minus I groups. Next, polarization produced in a molecule by interaction of two pi bonds or between a pi bond and lone pair of electrons present on adjacent atom is resonance effect or mesomeric effect. So polarity produced in a molecule due to conjugation. Next, transfer of a shared pair of electrons pi electrons to one of the two bonded atoms under the influence of attacking reagent is electromeric effect. Electromeric effect. Next, delocalization of sigma electrons of CH bond of alkyl group directly attached to unsaturated system is hyperconjugation or no bond resonance or Baker-Nathan effect. Baker-Nathan effect or sigma pi conjugation. Sigma pi conjugation. So number of hyperconjugative structures equal to number of hyperconjugative structures equal to number of alpha hydrogens. So stability directly proportional to number of hyperconjugative structures. Stability directly proportional to number of hyperconjugative structures. Very, very important. Next, types of organic reactions. So organic reactions in which reagent and substrate combine to give a simple product are addition reactions. Addition reactions. So in case of organic reactions, we have organic reactions. We have three parts: substrate, which is known as reactant, plus reagent gives product. Main three parts will be there: substrate, which is initial compound, reactant, next reagent, that is attacking reagent, gives product. This is basic selection of any organic reaction. Next, the organic reactions in which an atom or group of substrate is replaced by another atom or group are known as substitution reactions. Next, the reactions in which two or more atoms or groups of organic substrate are removed to form multiple bonds are known as elimination reactions. Next, the organic reactions involving rearrangement of less stable species to more stable species are known as rearrangement reactions. There are types of reactions. Very, very important. Next. So purification of organic compounds. The method used to separate sublimable compounds from non-sublimable impurities is known as sublimation. Iodine, naphthalene, benzoic acid separated by this technique. That means purified by this technique. Next, the solids which are having difference in solubilities are separated by crystallization. Next, the method used to separate volatile liquids from non-volatile impurities is known as distillation. So distillation is nothing but evaporation followed by condensation. Next, liquids which differ in their boiling points are separated by distillation. That means simple distillation can be used. Simple distillation is used when difference in boiling points will be greater than or equal to 40 degrees centigrade. 40 degrees. Fractional distillation. Fractional distillation is used when difference of boiling points less than 40 degrees or nearly same boiling points. Next, the chemical compounds are separated by heating them into temperature at which one or more fractions of mixture will vaporize is known as fractional distillation. So it can be used when boiling points difference is very small. Next, glycerol, ROL should be there. Glycerol can be separated from spent lye, which is basic substance, alkaline substance in soap industry by using distillation under reduced pressure or vacuum distillation. So glycerol can be purified by vacuum distillation because glycerol decomposes at its boiling point. Therefore, pressure can be reduced. Pressure will be reduced. Next, the method to separate substances which are steam volatile and are immiscible with water is steam distillation. Very, very important. So, orthonitrophenol, paranitrophenol mixture can be separated by steam distillation. Steam distillation. So here orthonitrophenol is having intramolecular hydrogen bonding. Intra-hydrogen bonding. This one inter-hydrogen bonding. Therefore, orthonitrophenol is steam volatile. So therefore, orthonitrophenol will be separated by steam, leaving paranitrophenol behind. So orthonitrophenol, paranitrophenol mixture can be separated by steam distillation. When steam is passed through this mixture, since orthonitrophenol is steam volatile, it will be separated from, that means it will be separated by steam. It will be mixed with steam, leaving behind paranitrophenol. Qualitative analysis, that means detection or identification of different elements in organic compounds. Carbon and hydrogen are detected by copper oxide test, that means cupric oxide test. So carbon and hydrogen are oxidized to carbon dioxide and water respectively. Carbon will be converted to CO2 and hydrogen will be converted to water. Next, nitrogen, sulfur, halogens, phosphorus can be detected by using Lessein's test or Lessein's extract or sodium fusion extract. Next, so ionic form of sodium nitroprusside is Prussian blue color. sodium nitroprusside. Next. So organic compounds with nitrogen and sulfur on reaction with sodium metal forms NaSCN, sodium thiocyanate. NaSCN, sodium thiocyanate. If organic compound contains both sulfur and nitrogen, that will be converted to NaSCN. Next. The amount of nitrogen present in organic compound can be estimated by Dumas method and Geldahl's method. Geldahl's method. Next, Geldahl's method is not applicable to organic compounds containing nitro group, azo group and nitrogen present in ring. So in these cases, nitrogen cannot be estimated. So nitro group means, NO2. Nitro. Next, azo group, N double bond N, azo. Nitro, azo group, nitrogen present in ring. So these nitrogen cannot be estimated. Pyridine. These are exceptions for Geldahl's method. Next. Halogen, sulfur and phosphorus can be estimated by Carrier's method. So detection or identification means qualitative, estimation means quantitative amount. See here, percentage of carbon, 12 by 44 into weight of CO2 by weight of substance into 100. Percentage of hydrogen, 2 by 18 into weight of H2O by weight of substance into 100. Substance means organic compound. Dumas method, percentage of nitrogen, 28 by 22400 into volume of N2 at STP in ml by weight of compound into 100. Next, Geldahl's method, 1.4 into normality of acid into volume of acid by weight of organic compound into 100. Next, Carrier's method, chlorine, 35.5 by 143.5 into weight of AgCl by weight of compound into 100. In case of sulfur, 32 by 233 into weight of BaSO4 by weight of organic compound into 100. Next, percentage of phosphorus, 62 by 222 into weight of magnesium pyrophosphate by weight of organic compound into 100. So this is estimation of different elements. Next, alkanes. So alkanes are saturated open chain hydrocarbons containing carbon-carbon single bonds. That means like this. So distance 1.54 angstrom units. sp3 and sp3. Next, general formula of alkanes, CnH2n plus 2, CnH2n plus 2. Next, methane is first member. Next, methane is found in coal mines and marshy places. Alkanes are also known as paraffins, that means little affinity. So due to saturation, these are less reactive. Carbon atom undergoes sp3 hybridization. Next, alkanes with more than 3 carbon atoms can show chain isomerism. Minimum number of carbon atoms, 4 should be. So butane, 2 isomers, pentane, 3 isomers. Next, so boiling point increases with increase in molecular weight of alkanes. So increase of chain isomers, boiling point decreases with minimum surface area. That means as the branching increases, boiling point decreases. Next. So ethane can form infinite number of conformations due to free rotation about carbon-carbon single bond. But two extreme conformations are possible, eclipsed and staggered. Staggered is more stable when compared to eclipsed. Next. Next points. In which hydrogen atoms attached to two carbon atoms as close as together is eclipsed. Eclipsed and staggered. Right here. So very important conformations. Eclipsed and staggered. Front carbon and back carbon. You can write like this. So this form is, so here say theta is approximately 0 degrees, dihedral angle, eclipsed. Next here, you can write one more form like this. Hydrogen atoms are far away. Here theta is 60 degrees, which is staggered. Staggered form. These are two extreme conformations of ethane. See here, in which hydrogen atoms are as far as possible is staggered conformation. So any intermediate conformation is Q or GOC conformation. Next, energy difference between these two is 12.5 kilojoules per mole. Remember this. Approximately 3 kilocalories. Next, carbon atom attached to one more carbon atom is primary carbon atom. Carbon atom attached to two more carbon atoms is secondary. 3 more carbon atoms is tertiary. 4 more carbon atoms is quaternary. Next here, alkane CC bond length 1.54 or 154 picometers. 1.54 angstrom units, 154 picometers. CH length 112 picometers. Next, so due to saturation, alkanes undergo substitution reactions. Next, preparations. So soda lime mixer. First one, soda lime mixer NaOH plus EaO used for decarboxylation. That means removal of CO2. Removal of CO2. So here example is given. Sodium propionate on decarboxylation gives ethane with loss of one carbon atom. CO2 will be removed. Reaction of alkyl halides. Alkyl halides on reduction will give corresponding alkanes. Reduction Zn and HCl. Woods reaction. Here 2 moles of alkyl halides with sodium metal in dry ether forms symmetrical alkanes. That means alkanes containing even number of carbon atoms. Next, coal-based electrolysis. Sodium acetate gives hydrocarbon, which is ethane and CO2 at anode, NaOH and H2 at cathode. Coal-based electrolysis. Coal-based electrolysis. Very important. So this is Woods reaction. 2 moles of alkyl halide with sodium at 2 moles of sodium in dry ether forms corresponding alkanes, symmetrical alkanes. Symmetrical alkanes. That means alkanes containing even number of carbon atoms. Very, very important. Next, this is coal-based electrolysis. Hydrocarbon and CO2 liberated at anode, H2 and NaOH at cathode. Next, addition of dihydrogen. So this is nothing but catalytic hydrogenation. Unsaturated compounds will be converted to saturated compounds, that is alkanes. Next, physical properties. So due to weak forces, first 4 members are gases, 5 to 17 are liquids and other are solids. Next, chemical properties. Nitroethane is a product obtained when C2H6 reacts with vapor phase nitration. At very high temperature, HNO3 will be in vapor state. So C2H6 gives C2H5NO2, and also we can write here CH3 vapor phase nitration. We can write like this. It forms nitroethane, so as well as nitromethane. Final product is nitromethane. So all possible bonds will be dissociated, will be broken. Next, combustion reactions. Combustion means reaction with oxygen. That means excess amount of oxygen, complete oxidation. So alkanes heating in the presence of air or oxygen forms CO2 and hydrogen changes to H2O with release of large amount of heat. The general equation. Next, isomerization. N-alkanes on heating in the presence of AlCl3 and HCl isomerizes to branch chain alkanes. Next, aromatization. So here conditions are high temperature and high pressure. Next, transition metal oxides are required as catalyst. So alkanes containing minimum of 6 carbon atoms undergo aromatization to form corresponding aromatic compounds. So N-hexane gives benzene. If it is heptane, toluene. If it is octane, that gives xylene or ethyl benzenes. Next, reaction with steam. Steam is very, very important. It gives CO and H2, steam. Next, mixture of CO and H2 is water gas. Water gas or synthesis gas. Next, pyrolysis. So decomposition of higher alkanes to lower alkanes and alkanes due to strong heating. So higher alkanes will be converted to lower alkanes and alkenes. Next, about alkenes, unsaturated hydrocarbons. General formula CnH2n. These are also known as oil forming, that is olefins. Alkanes are paraffins, alkenes are olefins. Next, hybridization of carbon is sp2, bond length 134 picometers and bond energy 384 kilojoules. Next, so dipole moment of cis compound will be more than that of trans compound. In trans compound there will be cancellation of dipoles. Next, alkenes show both structural and stereoisomerism. In stereo, most common geometrical. Next, preparations. So alkenes show addition reactions due to the presence of pi bonds, pi electrons. Next, so from alkynes, so very, very important, alkyne to alkene. Cis alkene is formed when alkanes are treated with H2 in the presence of PDBSO4 in quinoline. So here quinoline is catalyst poison. Next, transalkene is formed when alkynes react with H2 in the presence of sodium in liquid ammonia. This is Birch reduction. Birch reduction. So with Lindlar's catalyst, cis-alkene, with Birch reduction, transalkenes. From alkyl halides, dehydrohalogenation of alkyl halides will give corresponding alkenes. So here dehydrohalogenating agent is alcoholic KOH. Next, dehalogenation of vicinal dibromide will give corresponding alkenes. Dehalogenating agent is zinc. For dehydrohalogenation, alcoholic KOH, dehalogenation, zinc must be used. Next, from alcohols. So dehydration of alcohols will give corresponding alkenes. So here concentrated H2SO4 or N-hydro-Cl2O3 are dehydrating agents. Next, physical properties. C1 to C3 are gases, C4 to 14 are liquids, above are solids. Next, so chemical properties. So alkenes are rich source of pi electrons. So pi electron density is more in case of alkenes. Therefore, they can undergo addition reactions. Next, in some cases, free radical substitution reactions under special conditions. Addition of dihydrogen. Alkenes are converted into alkanes. Addition of halogen. That means this is a test for unsaturation. Br to red liquid will be converted to colorless. So alkenes or alkanes can decolorize red color of Br2. Test for unsaturation. Next. So addition of hydrogen halides. So these are best examples for electrophilic addition reactions. Alkenes and alkanes can undergo alkanes and alkanes undergo electrophilic addition reactions, while cyanides and carbonyl compounds undergo nucleophilic addition reactions. Remember these 2 points. Alkenes and alkanes, electrophilic additions. Cyanides and carbonyl compounds, nucleophilic addition. Next, here one more important point. According to Markovnikov's rule, propane reacts with HBr to give 2-bromopropane as major compound. So negative part of the reagent must be attached to carbon atom of double bond containing less number of hydrogen atoms, that is Markovnikov's rule. But in the presence of peroxide, negative part of the reagent must be added to carbon atom of double bond containing more number of hydrogens, that is anti-Markovnikov's addition. Next, so anti-Markovnikov's addition possible only with HBr, only HBr. Next, so order of reactivity of hydrogen halides HI, HBr and HCl. So addition of sulfuric acid, that will give bisulfate, ethyl bisulfate. Addition of water, corresponding alcohols. Oxidation with dilute KMnO4, glycols. Glycols will be formed. Those are known as vicinal diols or glycols. Glycols will be formed, vicinal diols. Next, acidic KMnO4 or K2Cr2 ozone oxidases alkenes to ketones or acids based on the structure of the alkene. Based on structure. Here we can see. Here doubly bonded carbon contains hydrogen. Therefore, it will be converted to formic acid. First, formic acid is most active. That will be converted to again CO2. So, a doubly bonded carbon contains no hydrogen. Therefore, that will be converted to ketone. So, ketones or acids will be formed based on structure of alkene. Check here. So, this carbon contains H. Therefore, it will be converted to COOH. Here also COOH. 2 moles of ethanoic acid or acetic acid. Next, ozonolysis. Ozonolysis of alkenes will give ozonide, which on cleavage by ZnH2O gives corresponding carbonyl compounds. So, in the presence of zinc, reductive ozonolysis. In the absence of zinc, oxidative ozonolysis. Next, polymerization. So, polyethylene is obtained by combination of large number of ethene molecules at a high temperature in the presence of catalyst. Ethylene to polyethylene. Next, large molecules thus obtained in polymerization process are called polymers and simple molecules are known as monomers. Single unit is monomer and combination of many units is polymer. Next, alkynes. So, unsaturated hydrocarbons with at least one triple bond or alkynes. General formula CnH2n-2. So, alkanes are derivatives of acetylene. Therefore, these are known as acetylenes. Acetylenes. So, hybridization of carbon sp. Next, 1 sigma, 2 pi bonds. Next, C double bonds, length. So, first strength 823 kilojoules. Next, length 120 picometers. That means 1.2 angstrom units. Next, alkanes are cylindrically symmetrical about internuclear axis. Therefore, these are stable. Next, so oxyacetylene is used for welding purposes. Oxyacetylene flame. It can release large amount of heat. Next, preparations from calcium carbide on hydrolysis. It gives acetylene. Next, from vicinal dihalides. So, alcoholic potassium hydroxide, that means dehydrohallucination gives corresponding alkynes. Next, so here alcoholic KOH and sodium amide are dehydrohallucinating agents. Next, dehallucination also gives corresponding alkynes with zinc dust. Tetrahalides, here we should take tetrahalides. So, vicinal dihalides means dehydrohallucination. Tetrahalides means dehallucination. Next, chemical properties. Acidic character of alkynes. See, acidic nature. sp hybridized carbon. Hydrogen atom attached to sp carbon will be more acidic. Acidic. More acidic alkynes. Least acidic alkanes. Next. Acetylene reacts with sodium. I found this on the web. Acetylene reacts with sodium to form sodium acetylide with displacement of H plus ions. Next, addition of halogen. Acetylene undergoes addition reactions with 2 moles of Br2. So, 1 pi bond means 1 mole of halogen is required. 2 pi bonds, 2 moles of halogen is required. So, this is also test for unsaturation. Here, red color will be decolorized. Br2 will be in red color. Next. So, addition of water. So, acetylene, first it gives vinyl alcohol which on tautomerism gives histolide. So very important for competitive exams. Next, addition of dihydrogen, it gives first alkene, next alkane. Next, addition of hydrogen halide. So on addition of hydrogen halides, they will form gem dihalides. Gem dihalides means two halogen atoms are attached to the same carbon atom. Next, cyclic polymerization. So in the presence of red hot iron tube or copper tube, 3 moles of acetylene undergoes cyclic polymerization to form benzene. Best method to prepare benzene. Next, aromatic hydrocarbons. Aromatic hydrocarbons are known as simply arenes. Next, aromatic compounds containing benzene ring are benzenoid aromatic compounds, which do not contain benzene ring are non-benzenoid aromatic compounds. Next, here benzene. So molecular formula C6H6 or CnHn. So these type of compounds are known as enolines. Hybridization of carbon atom in benzene sp2. So carbon-carbon bond length 1.39 angstrom units or 139 picometers. Next. So it is non-polar molecule. Charges will be 0. Burns with sooty flame. All aromatic compounds will give sooty flame. Next, preparations. Distillation of sodium benzoate with soda lime. That means decarboxylation of sodium benzoate gives benzene. Reduction of phenol with zinc gives benzene. 3 moles of acetylene in the presence of red hot iron or copper tube will give benzene. Hydrolysis of benzene sulfonic acid will give benzene. Properties, very important. So benzene undergoes aromatic electrophilic substitutions readily. Aromatic electrophilic substitutions. Halogenation takes place in the presence of Lewis acids. Chlorination of benzene in the presence of anhydrous AlCl3 gives chlorobenzene. Next, benzene on treatment with excess of chlorine in the presence of anhydrous AlCl3 gives hexachlorobenzene. Next, nitration mixture. 1:1 mixture of HNO3 and H2SO4. Concentrated mixture. Next, so benzene undergoes nitration in the presence of nitration mixture gives nitrobenzene. In this electrophile is nitronium ion NO2+. Benzene undergoes sulfonation in the presence of fuming sulfuric acid or oleum gives benzene sulfonic acid. Oleum is fuming sulfuric acid. Next, Friedel-Crafts alkylation. Benzene reacts with alkyl halide in the presence of AlCl3 to form alkyl benzenes. Similarly, benzene reacts with acyl halides in the presence of Lewis acids will give Friedel-Crafts acylation reaction. Here, acylation should be there. Acylation. Next, benzene reacts with here once acyl halide or acetic anhydride. Acylation only. Next, catalytic hydrogenation of benzene will give cyclohexane. Cyclohexane. Next. So benzene undergoes addition reaction with chlorine in the presence of sunlight gives gamaxine or lindane or benzene hexachloride. Next. Benzene reacts with 3 moles of ozone to form 3 moles of glyoxal. Next. So during electrophilic substitution mechanism, the carbocation will be formed, that is known as iridium ion or sigma complex. Next. The groups which can direct the incoming electrophile to ortho and para positions are known as ortho-para directing groups. Next, the groups which can direct incoming group to meta position or meta directing groups. Next, benzene and polynuclear hydrocarbons containing more than two benzene rings are fused together are toxic and said to be possesses cancer producing property. This is known as carcinogenicity. Next, this reaction is very important. CaC2 on hydrolysis will give first acetylene, that on passed through hot metal tube that undergoes cyclic polymerization to form benzene. Next, benzene on treatment with alkyl halide in the presence of AlCl3 gives toluene. Very important example. So this is about synopsis of general organic chemistry. So next we will discuss questions one by one. See first question. 1-chloro 3-methyl butane. That means 1, 2, 3, 4. Say this is 1, 2, 3, 4. 1-chloro 3-methyl butane. So remaining all are hydrogens. Reaction with Zn and HCl. So reduction. 2 moles of nascent hydrogen. We can add like this. It gives CH3, CH2, CH, CH3 and CH3. So 2-methyl butane. 2-methyl butane. A is the option. Reduction. Reduction of alkyl halides to corresponding alkanes. And HCl will be released. HCl. HCl is byproduct and it will be used again. Next. An organic compound cyclohexane 3 and 1 vol. Take here 1 vol. So this is 1, 2, 3, 4, 5, 6. 3 in. 3 in means like this. 3 in. 5 allyl. CH2, CH double bond CH2. This is allyl group. This compound is given. So this compound on reaction with cold and dilute cheminophore. That means simply cold cheminophore gives, which is Bayer's reagent. Here 1 OH and here also 2 OH groups will be there. Next CH2, CH, CH2, here 2 OH groups. So total the number of hydroxyl groups present in the product is 1, 2, 3, 4, 5. So D is the answer. Synhydroxylation reaction. Synhydroxylation. Very important. Next. Next question. Very important. Correct order of stability. So first take A compound. A compound is so tertiary. and it contains 3, 2 and 1. That means number of alpha hydrogens we can count. So here CH3 means 3, 2, 5 and 6. 6 alpha hydrogens will be present. 6 alpha hydrogens. Next. After that D. D also tertiary, and which contains, so 1, 2, 3, 5. 5 alpha hydrogens. So stability directly proportional to number of alpha hydrogens. So after that take C. C is secondary. Next after that B. B is primary. Stability order. So this is decreasing order. We can write increasing order B, C, D, A. Therefore option C. This is increasing order. Not increasing order. This is decreasing order. Decreasing order of stability. We can write increasing order in reverse way. A is more stable due to tertiary and 6 alpha hydrogens are present. Next D. D is also tertiary, but 2 plus 2 plus 2, 2 plus 2 plus 1, 5 alpha hydrogens. Next. So major compound. So first OH. First reaction with zinc. Zinc dust, it gives, zinc is reducing agent. It gives just benzene. With elimination of Z and O. Z and removes O from phenol. This is phenol. Next, which are reaction with Cl2FeCl3. Chlorination of benzene. Chlorination will give chlorobenzene. Chlorobenzene option D. Halogenation. Halogenation in the presence of Lewis acid. Next. The major products P and Q. So here it is given CH3, C triple bond C, C2H5. So first reaction, Lindlar's catalyst. Lindlar's catalyst. Second reaction, sodium in liquid ammonia, which is bit reduction. Bit reduction. So very, very important. Bit reduction. Light compounds. So with Lindlar's catalyst, it forms very, very important. Next here it gives transalkane. So which is option C. P is cisalkane and Q is transalkane. Next. So identify chiral molecule among the following. We take pentane 2-ol. Pentane 2-ol. Here 1, 2, 3, 4, 5. Here it is chiral center. Carbon atom attached to 4 different atoms or groups. Therefore, this carbon will be chiral carbon. Therefore, molecule is chiral molecule. Option B. Carbon atom attached to 4 different atoms or groups. Next. So, propane subjected to reaction with HgSO4 dilute H2SO4. See here, propane with H2SO4, HgSO4. So addition of water here. So plus H2O we can write. So according to Markovnikov's addition, we can add water molecule. C double bond CH. So here OH and here H. So this is enol form, which on tautomerism forms acetone. So mechanism will be like this. CH3CO CH3 acetone. So next reaction, resulting compound is P. Here it is given P. Next, P with BaOH twice. So which is aldol condensation. Take 2 moles BaOH twice, aldol condensation. It gives final compound. Here also heating must be there, followed by heating. Double bond CH CO CH3. So alpha beta unsaturated ketone. So molecular formula they are asking 1, 2, 3, 4, 5, 6. C6 molecular formula, hydrogens 6, 7, 8, 9, 10, and O is the molecular formula, final compound. Option D. So first reaction, hydration of alkynes. Next reaction, aldol condensation. Next, the correct order of rates of addition of Br2 to the following. So this is electrophilic addition. Electrophilic addition. So alkenes and alkanes undergo electrophilic addition. So therefore we can check stability of carbocation formed. Stability of carbocation you can check. Next, so first compound D will give more stable carbocation. After that C will give, so D tertiary carbocation, C will give secondary carbocation. After that A, at last B, because NO is electron withdrawing group. So carbocation will not be formed. So A gives only primary. So electron withdrawing group is present. Therefore, it cannot form carbocation easily. This is the order. Option A. So D compound will form tertiary carbocation, which is highly stable. Next C, secondary. After that, between A and B, A can form primary, which is stable when compared to B, because B contains electron withdrawing group that can destabilize carbocation. D, C, A, B. So this is the rate of reaction. Or stability of carbocation. stability of carbocation. So option A. Next. So decreasing order of stability of given carbocations. So here also we can check first B. B is a tertiary carbocation. After that D secondary. So D secondary and it contains 4 alpha hydrogens. After that C also secondary, but it contains only 3 alpha hydrogens. After that A is primary. This is stability order. So B, D, C, A. C option. So based on number of alpha hydrogens, stability directly proportional to number of alpha hydrogens. Next. So benzene reacts with N-propyl chloride. Benzene reacts with N-propyl chloride in the presence of AlCl3 gives isopropyl chloride. That means isopropyl benzene. So first here CH3, CH2, CH2 plus primary carbocation will be formed. So which on rearrangement gives secondary carbocation which is more stable. So this is electrophile here. That can attack benzene ring to form isopropyl benzene which is known as cumene. Cumene option B. Next. In which of the following reactions tertiary butyl benzene is formed? So in first reaction it will be formed benzene with tertiary butyl chloride. CH3Cl AlCl3 it gives CH3 thrice tertiary butyl benzene. Second, it also gives benzene plus CH3 twice C and CH2 in the presence of BF3 Lewis acid and HF. It gives same compound tertiary butyl. Next 3 benzene plus tertiary butyl alcohol in the presence of H2SO4. So first OH will be removed to form tertiary carbocation. It will also form CH3 thrice. In last compound, option A plus butanoyl chloride. CH2COCl. In the presence of AlCl3, it gives, so very important, C double bond O, CH2, CH2, CH3. This is not tertiary butyl benzene. Therefore, 1, 2, 3 is the answer. Next. So, which of the following chemicals can be used as dry cleaning agents? So, here A, B and C are used in dry cleaning. Dry cleaning, option B, uses only. Next, when propane is passed through red hot iron tube, propane CH3 C11CH propane, take 3 moles red hot iron or copper tube. It undergoes cyclic polymerization to form mesitylene or symmetrical benzene or trimethyl benzene, mesitylene. So here molecular formula is carbon atoms total 6 plus 3 9, hydrogen atoms 3 3 3 9 plus here one hydrogen and hydrogen H12. H12 must be there here. C9H12. Very, very important. Therefore, option B, mesitylene. Next. So, identify starting compound P in the following reaction. So, here, last compound is CH3, CH3, CH2, CH2, CH3 and CH3. This is the compound, final compound. So, sodium in dry ether. So, initial compound will be dissociate like this. You can take 2 moles of CH3, CH3, CH2Br we can take. So that is 1, 2, 3. So 1 bromo, 2 methyl, 2 methyl propane. So option A, initial compound. Starting compound P. Woods reaction. Woods reaction. Next. An unsaturated organic compound X on reaction with hot acidified gives succinic acid. So what is X? To take cyclobutene with hot KMnO4. So dissociate like this. Here this will be converted to COOH and this carbon will be converted to COOH. Therefore CH2, CH2, COOH and COOH, which is succinic acid. Very, very important. So CH will be converted to COOH. Option C, cyclobutene. Next. So product Q of the following reaction. So first benzene with CH3, CH2, COCl in the presence of AlCl3, it gives CH2, CH3. Next, Clemenson's reduction, ZnHg and HCl. So CO group will be converted to CH2. Therefore, it will give CH2, CH2, CH3. Propyl benzene. N-propyl benzene. So option B. Next, identify ortho and para directing groups in the following. See here, OH, lone pair is present. Next, O, CH3, lone pair. Next, NH, CO, CH3, here also lone pair. So electron donating group, and here also electron donating group. So electron donating groups are ortho and para directing groups. Ortho, para directing. So that is A, 1, 4 and 5. Here 1, 4 and 5. Option A. Next, the compound or ion which is not aromatic in nature. So here 2 double bonds and plus. So it obeys 4n pi electron rule. 4n pi electron rule. So therefore 4n pi electron rule, multiples of 4, that is anti-aromatic. Anti-aromatic compound. Option B. Remaining are aromatic. So this is B, A, C, D are aromatic. Next. So in Lesson's sodium fusion extract, if N and S are present in organic compound, that will be converted to. So if organic compound contains N and S, if that is heated with sodium, that will be converted to NaSN or NaSCN, CNS or SCN, sodium thiocyanate. Sodium thiocyanate. So option C. Okay, next. Organic compound with molecular formula C6H6Br has 6 carbon atoms in ring structure. 6 carbon atoms in ring structure and 2 non-conjugated double bonds and 2 bromine atoms at 1 and 4 positions. Here Br and Br 1, 2, 3, 4, 5, 6. So then the compound is homocyclic. That means containing only carbon atoms in ring. Only carbon atoms in ring. And so here not aromatic. Conjugated system is not present, therefore not aromatic. Therefore option C. Next. So which are the following compounds is most reactive towards electrophilic reagents? Check here. CH3 is electron donating. That means activating groups. Next, OH also same, lone pair, electron donating group, activating. Therefore, this compound is most reactive. Most reactive towards electrophilic substitution. Electrophilic substitution. Option C. In first compound also 2 electron donating groups are present, but when compared to CH3, OH is more donating. Next. So sodium acetate on coal base electrolysis will give ethane. Sodium acetate, if you take 2 moles, CH3COO sodium acetate, 2 moles at anode, hydrocarbon, that is ethane, plus 2 moles of CO2 will be formed. Next, at cathode, so 2 moles of NaOH plus H2 will be formed. So free radical is formed at anode, but here cathode is given. So A is true, R is false. Option C. So methyl radical is formed at anode. Next. In Lesson's test for halogens, it is necessary to remove X and Y compounds from sodium fusion extract. XY compounds are NaCN and Na2S. So when these are boiled with HNO3, so these compounds will be converted to HCN and H2S. These are volatile compounds. That means sodium cyanide and sodium sulfide will be converted to volatile compounds, hydrogen cyanide and hydrogen sulfide. These will be eliminated. So here option D. Sodium cyanide will be converted to HCl, Na2S will be converted to H2S, volatile compounds. Next. In agricultural field, which among the following is highest producer for methane? So paddy crop is best source of methane. Option B. Next. So non-aromatic compound among the following is. So take this compound. Here this carbon contains 2 hydrogens and which is sp3 carbon. If compound contains at least one sp3 carbon, this compound will be non-aromatic. Non-aromatic due to sp3 carbon. Option B. Remaining are aromatic. Next. So type of hybridization 5 carbon atoms from left to right. Pent 1, 2, 3, 4, 5. Pent 1 in 4 ion. 1, 2, 3, 4. 4 ion. Remaining are hydrogens. Here 1 H, Here 2 hydrogens, here H. Here this carbon is double bond sp2, sp2, all single bonds sp3, sp and sp. 1, 2, 3, 4, 5. So sp2 must be there here, comma, yes, comma, sp2, sp2, sp3, sp, sp. Option A. Here also comma. Comma. Option A. Next. So here hybridization change CH3, CH double bond CH, CH2OH, primary alcohol. So here PCC should be there, PCC. Or PDC you can write. Mild oxidation. So PCC will be mild oxidizing agent. Mild oxidation. Here it will be converted to CH3, CH double bond CH and C double bond OH, aldehyde. Aldehyde. So here this carbon is sp3 carbon and this carbon is sp2 carbon. Right here aldehyde. This is sp2. So sp3 to sp2. Therefore option B. PCC is mild oxidizing agent. Conversion of primary alcohol to aldehyde. Next. So IUPAC name for this compound is, so here CO should be here, CO. C double bond O. CO and here CO. That means CH3, CO, CH2, CH2, COOH. 1, 2, 3, 4, 5. So total 5, 4 oxo or keto we can write. Pentanoic acid. 4-oxo-pentanoic acid B. So main functional group is COOH. CO becomes substitution. 4-oxo or keto. Next. Resonance effect is not observed in. So in A, B, C there is conjugation, but in case of D, CH2, CH, CH2, NH2, here no conjugation, between pi bond and lone pair. Therefore, resonance is not observed. Resonance is not observed. So option D. In remaining cases, conjugation is present. Next. In which of the following homolytic bond fission takes place? Homolytic bond fission. So free radical chlorination. That means in halogenation of alkanes, free radical substitution takes place. Very, very important. That means free radical chlorination of methane. So option A. So I will write one example. So first chlorination of methane means step 1. ClCl in the presence of sunlight dissociation like this. 2 moles of Cl radicals will be formed. Homolytic fission. Step 2. So this Cl radical attacks CH4 to form CH3 radical plus HCl. So this is chain propagation step. Radicals are formed. Next. This is the end of the chapter. In next video I will explain one more chapter. All the best and thank you.